Hello students, how are you all? So today we will be starting with a new chapter, that is lines and angles. Okay, so taught you the previous chapters like the polynomials which you are doing now. Then we have done the pair of linear equations in two variables, right? So today we will be starting with chapter 6, that is lines and angles, and this chapter is very important because for whole trigonometry part, trigonometry and this geometry part. So for the geometry part you will need this chapter, okay, and you need to know whatever we have learned here very properly, okay, then only we will be able to do the upcoming sums. Okay, so now see here, in daily life we have seen various examples of lines and angles. Okay, so just for example, if you need to build a house, so definitely the workers use measurement tapes, then they use some specific lines and angles to build the house, then only it can be a straight one, otherwise it will not become straight, right? So therefore lines and angles are very important in day-to-day life. So from earlier classes 6, 7, 8, okay, this all the classes you all have learned about various lines and angles, like, right? For example, like the acute angle, okay, like a straight line, okay, this is a straight line. So this is a straight line, right? So and you all have read about the acute angle. So this is an acute angle, right? And also you have learnt about obtuse angle, right? Then you have learnt about right angle, which is 90 degree, right? All these things you all have learnt in the previous classes. So here are some important terminologies we need to understand first. So what are the terminologies? Okay, so if a line has two end points, that means if this line has two end points, this is one point and this is one another point, this is A and this is B. So this line we call it as, if the line has two end points, we call it as line segment. Okay, okay, if this line has only one end point, that means there is only one end point, okay, and it goes on like this, so we call it as a ray. Okay, so we call it as ray. And this line segment AB, which have two end points, it can be denoted as A, B, bar. Okay, it can be denoted as A, B, bar. And the ray, if I point it as AB, I can write as A, B, like this, a ray. Okay. Now see here, if I say that if these 3 points, this is one point, this is one point and this is one point, if these 3 points lie on the same plane or same line, okay, then we call these points as collinear points. Okay, but if they don't lie, suppose one lie here and another lies here, so see, these 2 points lie on the line but this point doesn't lie on the line, so that means I will call these points as non-collinear points. Okay, so I'll call it as non-collinear points. Okay, and See, what is an angle? An angle has two arms, right? So this is one ray and this is one ray, and their end point, one end point meets its other. So we call this as an angle, right? We call it as angle. So what are they? They are the arms of the angle. They are the arms of the angle. Okay? And what is it called? This point is called as vertex. Right? This point is called as vertex of the angle. Okay. Now see here. If I make this angle, okay, if I make this angle, so this is one ray and we call this as arms, right? We call it as arms, and this point is the vertex. So this is an angle, and it makes some angle, right? So since this line will be 0 degree and it goes on increasing like this, and you all know that this straight line, this whole part is 90 degree. But if this ray makes some angle with this line, then definitely this angle will be somewhat between 0 degree to, say, this angle is x, and less than 90 degree. So what I will call this angle? I will call this angle as acute angle, right? So acute angle is always greater than 0 degree and less than 90 degree, right? So this is an acute angle. Okay. Now next, you already know what is a right angle, right? So from here to here it makes a perpendicular with this line. So this is 90 degrees. So that means for a right angle, what is the angle? It is right angle, x is equals to 90 degree, right? Or else you can write it like this: x is equals to 90 degree. For an obtuse angle, see, this is a ray and this is a ray, and this line is just 90 degree and it exceeds 90 degree or not. So therefore this angle is known as obtuse angle, and obtuse angle is always greater than 90 degree but less than 180 degree. If I make it a straight line, then definitely it will make 180 degree, right? So therefore obtuse angle is equals to 90 degree x 180 degree, right? So it will be greater than 90 degree but less than 180 degree. So we call it as an obtuse angle. Okay, but if it is a straight line, I already mentioned that it will be 180 degree. Since 90 plus 90, it will be 180 degree. So straight line this is a straight line. Straight angle is always x is equals to 180 degree. But now see here, this line from this point, it can further go on like this also, like this also, like this also, and like this also, right? It can move on, it can turn on from here to here, right? So what I will call this angle as? I will call this angle as reflex angle. So that means if this line, it goes on like this, like this, like this, it goes on like this, it goes on like this, and it gave a whole turn, then it is known as reflex angle, right? And reflex angle is always greater than 180 degree but less than 360 degree. If it will make 360 degree, then it is a circle, right? So reflex angle is always greater than 180 degree and less than 360 degree. So just you need to understand these basic things first. Okay. So further, two angles whose sum is 90 degree are called complementary angles, and two angles whose sum is 180 degree is called supplementary angles. So what are complementary angles? What are complement? I have already made the diagram. If this is a straight line, and this angle is 90 degree, and again this angle is 90 degree. So a straight line has to tell 90 plus 90, that is 180 degree. That means a straight line has 180 degree, and these two angles are known as, they are known as complementary angles. Okay, they are known as complementary angles. Okay, but if the two angles whose sum is 180 degree, okay, now see, if this is a straight line and say this is 90 degree, right? This part is 90 degree, and if I draw a ray here, okay, so this angle is say 45 degree and this angle is say 45 degree. What is the total degree? It is 90 degree, right? 45 plus 45. So both these angles are known as complementary angles. Okay, they are known as complementary angles. But if the same straight line I draw it like this, and this angle is 90 degree and this is also 90 degree, so that means the straight line has both 90 degree plus 90 degree, that is 180 degree. So we call these two angles as supplementary angles. Okay, so understood what is complementary angle and what is supplementary angle. Okay, so now what is a adjacent angle? Adjacent angle is nothing that if they have the same vertex. Okay, if they have the same vertex, then this angle is known as adjacent angles. Okay, if the two angles have the same vertex, that means if say this is the vertex A, okay, this is a ray and I have drawn again one ray here. So this angle and this angle are known as adjacent angles. Okay, these angles are known as adjacent angles because they have the same vertex. Okay, so next, linear pair of angles. So linear means what? Linear means a straight line. So if I call it as a linear pair of angles, then definitely there must be some angle. Say this is an angle, this is another angle, right? So this is known as linear pair of angles. For linear pair of angles, linear pair means what? It is a straight line, that means 180 degree. Okay. Next, vertically opposite angles. If I draw a graph like this, okay, so what is a vertically opposite angle? This angle and this angle, they are vertically opposite angles or not? Okay, so these are known as vertically opposite angles. Again, this angle and this angle, they are also known as vertically opposite angles. Vertically opposite angles. Okay, they are known as vertically opposite angles. Next, see, if the two lines, say this one is a line and this one is a line, if they intersect each other at a point, they are known as intersecting lines. Intersecting lines. But if if two lines run parallel to each other, then they are known as parallel lines. Okay, they are known as parallel lines. Next, you need to know the pair of angles. Okay. So first of all, you just need to know this axiom 6.1. See, this is very important. If a ray stands on a line, then the sum of two adjacent angles so formed is 180 degree. That means if a ray stands on a line, if a ray, any ray, it can be like this, it can be like this. That means if a ray stands on a line, this is a line. Okay, if a ray stands on a line, this can be a ray, or I can draw it like this, this can be a ray, right? Or this can be a ray, I can draw it like this also. If this is a straight line AB, this is a straight line AB, this is a straight line AB. So there can be any kind of ray which stands on this line. Okay, so then the ray stands on a line. So if they are what angles? They are adjacent angles or not? They are adjacent angles is how many degree? The straight line has 180 degree, right? 180 degree. Okay, so their adjacent angles is 180 degree. Sum of the two adjacent angles, right? If a ray stands on a line, then the sum of the two adjacent angles is 180 degree. Understood? This is what this axiom speaks. Okay. Next. Axiom 6.2. If the sum of two adjacent angles is 180 degree, then the non-common arms of the angle form a line. Right? So that means if the sum of two adjacent angles, if the sum of two adjacent angles is 180 degree, then the non-common arms of the angle form a line. Non-common arm. So it is like this. So say this is a line. Okay? And if a ray stands on this line and this adjacent angle is 180 degree, this plus this is 90 degree, this is 90 degree, so it becomes 180 degree, right? So they are known as, these two angles are known as adjacent angles. So since this one and this one are non-common, they are facing opposite to each other, right? One is facing this side and another is facing this side. So that means then the non-common arms form a line. That means this is a non-common arm and this is hence this is we call it as a line. Okay? So these above two axioms are together called linear pair axiom. Why? Why linear pair? Because this angle makes 180 degree. This angle 90 degree makes 180 degree. Again this one and this one makes 180 degree. That means the adjacent pair, this is for axiom 6.1 and this is for axiom 6.2. So both axiom 6.1 and axiom 6.2 are known as linear pair axiom. Why linear pair? Because I have already mentioned that for linear pair the angle is always 180 degree. Understood? So this is the basic things we need to understand. Okay? So now theorem 6.1. So here it is given that if two lines intersect each other, then the vertically opposite angles are also equal. So we need to prove this. Theorem 6.1. So what it is given? If two lines intersect each other, that means there are two lines and they are intersecting each other at a point, right? So if they intersect each other, then the vertically opposite angles are equal. So this is if this is the angle, this should be the angle. So they are vertically opposite angles. If this is the angle, then this will be the angle. So they are vertically opposite angles, right? Right? So they are vertically opposite, these two and these two. Okay. So now let me mark it as A, B, C and D. Okay. And these are two lines which intersect each other at point O. Okay. So given two lines AB and CD intersect each other at point O. Okay, it intersect each other at point O. What we need to prove? That the vertically opposite angles are equal. So we will write to prove. To prove, what we need to prove? Vertically opposite angles are equal. Okay, this is what we need to prove. That means angle, what are the angles? AOC is equals to angle BOD, right? So angle AOC is equals to angle BOD. Again, next, angle AOD is equals to angle BOC. Okay, angle AOD is equals to angle BOC. Now proof. Now see here, on the line AB, on this line AB, by linear pair, if this is the line AB, right? This is the line AB. So for linear pair of line, this is one ray here, right? This is D here, right? So this angle and this angle, they are adjacent angles and they make this straight line as 180 degree. That means for linear pair, that means on line AB by linear pair, what we know? We have seen here that angle, if this is point O, so AOD plus angle BOD is equals to 180 degree, right? So by linear pair, angle AOD plus angle BOC, you can take this also, or you can take, if I take this side, I can take this side also, right? This is C. Okay, so I can take this side also, this angle and this angle. This is both are 90 degree, right? Right? So angle AOD or AOC, you can take AOC plus angle BOC is equals to, what is the angle? It is 180 degree. Let this be equation 1. Okay. Next, again, on line CD. Now, CD is the line. This is the line. CD is the line. Okay. CD is the line. By linear pair, what we can do? If I take this ray, so that means A. This angle and this angle are, they are adjacent angles, and this makes sense. CD makes a line which is equals to 180 degree, right? So therefore, on line CD by linear pair, what you can do? Angle AOD plus angle AOC is equals to AOD and AOC, right? So which is equals to 180 degree. right? Now from 1 and 2, let this be equation 2. Now from 1 and 2, what we can do from 1 and 2? See here, angle AOC plus angle BOC plus equals to angle, since the right hand side have 180 degree as common, so we can write angle AOC plus angle BOC is equals to angle AOD plus angle AOC, right? From 1 and 2, angle AOC plus angle BOC is equals to angle AOD plus angle AOC, right? Now AOC and BOC. Now see here, AOC, if I take this to the left hand side, then or else you can directly cancel it out, AOC, because they both have common, which implies what is remain? Angle BOC is equals to angle AOD, right? Okay, so we have proved the first part, that is angle BOC is equals to angle AOD. This one is proved. Next, we need to prove angle AOC is equals to angle BOD. Okay, so again, on line AB. Again on line AB. Now see here. First of all, we have taken this line, right? Now, if I take AB as the line and this D as the ray, so that means A, B and D here. So this is, these two are adjacent angles and this AB makes 180 degree. So this time angle AOD plus angle BOD is equals to 180 degree. So on line AB, by linear pair, angle AOD plus angle BOD is equals to 180 degree, which is equation number, say this be equation 3. Okay. Now again on line CD, next on line CD, first of all we have taken as the ray this one, right? So this time we will take this part, that means it will look like this, right? So this is B, this is C and D, and this is O. So they are adjacent angles and this ADS will be 180 degree. Okay, so therefore I can write on line CD, what I can write? By linear pair angle AOD plus angle AOC is equals to 180 degree. Let this be equation 4. Now from 3 and 4, what we have got? Angle AOD plus angle BOD. AOD plus angle BOD is equals to angle AOD plus angle AOC. Now see, AOD got cancelled out. What we have? Angle BOD is equals to angle AOC. Angle BOD is equals to angle AOC. Hence we can write, therefore vertically opposite angles are equal. Okay, this is the required, hence proved. Okay, this is the required proof. Okay, vertically opposite angles are equal. Okay, so vertically opposite angles are equal. This is the required proof. So some examples are given here. By using this, you can directly find out the this formula only you can find out the proof. Okay. Okay. So let's start with exercise 6.1. So now see. See the first question. In the first question, it is given that in figure 16.13, one figure is given here. AB and CD intersect each other at point O. If angle AOC, this angle AOC plus angle BOE equals to 70 degree. This angle and this angle, if we add it, it will give 70 degree. And angle BOD, this angle is 40 degree, right? Given. We need to find angle BOE. First of all, we need to find this, and then we have to find the reflex CONE. That is the reflex COE. Okay? So we need to find this. So how we will do it? So from the given diagram. So I will not draw the diagram. You just look it from here. Okay? So from the diagram, we have what we have? Angle AOC plus angle BOE plus angle COE, this angle also. So this triangle makes a straight line or not? This is a straight line or not? Right? This is a straight line. So it is making a straight line. So angle COE is COE. You can write it like this. Equals to 180 degree, since it is a straight line, right? Next again, if CD is a straight line, then what are the angles? First of all, this is the angle, first angle, right? This is the second angle, this is the third angle. And also you can write and angle COE plus angle BOE plus angle DOB, right? Or else you can write BOD plus angle BOD is equals to 180 degree, right? Since they are straight lines, since you can write here AB and CD are straight lines. AB and CD are straight lines. Therefore, angle AOC plus BOE plus COE is equals to 180 degree, and angle COE plus BOE plus BOD is equals to 180 degree. Right? Now, given, what is given? First of all, angle AOC plus angle BOE is equals to 70 degree. It is given. Next, what is given? Angle BOD is equals to 40 degree. What we need to find? To find angle BOE and the reflex angle COE. Right? Reflex angle COE. So therefore, we will put the values. Therefore, AOC plus BOE, AOC plus BOE. That means we will get the value of COE. Right? COE. And reflex means what? Reflex means if this is a line, if I have to draw a reflex, then reflex makes an angle 360 degree, right? It will make total 360 degree. So therefore from here, what we can do? From equation 1, let this be equation 1 and this be equation 2. So from equation 1, angle AOC plus BOE, AOC plus angle BOE plus angle COE is equals to 180 degree, which implies AOC plus BOE is 70 degree, it is given, right? Plus angle COE is equals to 180 degree. That means, which implies angle COE is equals to 180 degree minus 70 degree, which is equals to 110 degree. So now what we need to find? We need to find reflex. Therefore, reflex angle COE is equals to 360 degree minus 110 degree, right? So which will be equals to 250 degree. That means this reflex angle, this whole reflex angle COE This whole is how much? 250 degree. Okay. Next, what we need to find? We need to find angle BOE. Therefore, for angle BOE, what we have? See, we have angle BOD as 40 degree. We have angle COE, right? Then we can find angle BOE. Therefore, from equation 2, what we have? We have COE plus BOE, angle COE plus angle BOE plus angle BOD is equals to 180 degree. So we have angle COE, we have found out already as 110 degree, right? Plus angle, we need to find angle BOE plus angle, what is BOD? BOD is given as 40 degree, right? Plus 40 degree is equals to 180 degree. That means, which implies angle BOE is equals to 180 degree minus of 110 degree, which is equals to 110 plus 40, that means 150 degree, which is equals to 30 degree. So therefore, angle BOE is equals to 30 degree and reflex angle COE is equals to 250 degree. Hence, this is the required answer. Okay, this is how you can find the required answer. Okay, so I have taught you the basic things. Now in the next class we will be completing this exercise and move on to the next part, that is parallel line and a transversal. Okay, thank you.